Ethanol is capable of directly causing insulin resistance at the level of the cell and at the level of the whole body in human studies. There are multiple methods for this, or multiple mechanisms that cause that intermediate that act as intermediary here, causing the insulin resistance in response to the ethanol. And ceramides are likely an end part. That's the ceramides, as I've discussed previously, directly come in and prevent the phosphorylation or the activation of a critical enzyme called AKT in that insulin pathway. So that's the direct effect. Now let's move on to the indirect effects. And by now you are familiar with my affection for alliteration, sorry. And that, so of the three indirect effects, I want to talk about sugar, sleep, and substrate. So these are the three S's of the indirect causes of insulin resistance in response to alcohol. All right, so the first one being sugar. The reality of many alcoholic beverages is that they're loaded with sugar. This is cocktails, beers, and some sweet wines. All of them contain either modest to very high amounts of sugar. Consider that in light of some of the human evidence I just mentioned, that when you combine glucose with ethanol, you are amplifying the effect. Ethanol alone isn't eliciting an insulin response. That's probably an important point I should have made. Ethanol alone is not inducing an insulin response, but it's not often consumed alone. It's often consumed as something else, whether it's the sugar in the drink or whether it's some of the starches in the nuts or whatever else the person may be eating while they're drinking that alcohol. But again, often sugar is present in some form, and this exaggerates the combination, amplifies the not only glycemic response, resulting in a significantly higher glucose level, but also a significantly higher insulin level. So insulin is working harder and ultimately failing, but all seeking to try to control the blood glucose response. And as you can imagine, as the individual continues to consume alcohol like this, day in, day out, that starts to contribute to a more chronic settling in of insulin resistance. Now let's move on to the next one. Sugar is an obvious one, but let me just again state it, that the excessive consumption of carbohydrates results in insulin resistance. Human evidence has shown that that high carb consumption can cause insulin resistance in just as little as 7 days. Also, if you have healthy insulin sensitive people eat just about 300 grams of carbs, which is not hard to do, their insulin is elevated for up to 10 to 12 hours. So it's easy to see how you can start stacking on these chronic insulin bumps, whereas one individual insulin spike isn't inherently pathogenic. It's when you continue to do this, which most people do, because most people consume a lot of refined starches and sugars, and they do so very often. Okay, so sugar is the first one of the indirect effects of alcohol causing insulin resistance. The next one is sleep. This one is surprising to most people because most people consider that alcohol consumption helps people sleep. What is true, and we'll cite a couple specific studies in a moment, is that alcohol increases or rather reduces the length of time it takes to fall asleep. In other words, people will fall asleep more quickly. But the impact of alcohol on sleep quality is that it disrupts sleep patterns and reduces overall sleep quality. And overwhelmingly, people will sleep poorly in response to alcohol. A poor night of sleep, this is its own topic of a metabolic classroom, is capable of causing insulin resistance. So let me just restate that. Even one bad night of sleep will cause demonstrable, obvious, quantifiable insulin resistance in humans the next day. Now, thankfully, one bad night can be corrected by one good night, but as you can imagine, as you continue to compound one bad night after another, the insulin resistance is a little stickier. One good night isn't going to be enough to wipe it out. And that is overwhelmingly a result of the stress hormones, particularly cortisol. So one bad night of sleep increases cortisol the next day, and cortisol will cause insulin resistance rather quite directly. And as you know from previous metabolic classrooms, cortisol is one of the primary causes of insulin resistance. Independent of any other stimulus, cortisol can cause insulin resistance, and just as a point of interest, does so by increasing ceramides within the cells of the body.